Today we're going to look at graphing exponential functions and finding their characteristics. Remember, exponential functions are all of the form y equals a times b to the x minus h plus k. A is your stretch, shrink, or reflect. X minus h is your left or right shift, and k is your up or down shift. So the first thing I see when I see number 1 is I want to graph this function here. To do that, I need to make a table of values. Now you can pick whatever numbers you want to go in your table of values, but the easiest numbers to choose are -2, -1, 0, 1, and 2. Now you can take these values of x and you can plug them in for x here and use the order of operations to find y, or you can use your graphing calculator. In your graphing calculator, you're going to hit the y equals button. If you have anything in any of the rows, you need to go ahead and clear it out. And I'm going to type in my equation. It's -5, exponent button, x, and then I have -3. Notice how this -3 is not a part of the exponent. So I need to get my cursor out of my exponent by hitting the right arrow. Now I'm back down and I'm going to do -3. If I hit the graph button, that's going to show me the graph of the equation, but I need to have the points in order to graph it. So I'm going to go to my table. So I'm going to do second table. And I want to start with -2. So -2 is -3.04, then -3.2. So -3.04, -3.2. 0 is at -4, -8, and -28. So -4, -8, and -28. So now I can plot these points on my grid. So I have -2, -1, 2, 3.04. Then I have -1, -3.2. And then I have 0, -4, 1, -8. And then 2, -28 is way off my graph, so I'm not going to worry about graphing that one. I cannot connect these points in a line until I have my asymptote. Your asymptote is always your k value, so it's always y equals k. So again, k is that number here on the end. So here my k value is -3. So my asymptote is going to be y equals -3. Y equals -3 is a horizontal line that goes straight through where y is -3 on your y-axis. So this is the asymptote y equals -3. So when I go ahead and draw my curve, I'm going to get really close to that asymptote, but I'm not going to cross or touch it. So I go up and we're going to curve. And we're going to get really close to that asymptote, but we will not cross or touch it. So here is my graph. If you forget to include your asymptote, you will lose points on a test or a quiz. You have to include it. Next, we're going to look at our transformations. Your transformations are your A, H, and K values. So A, H, and K. So my A value is a number that's out in front. It's my coefficient of my base. The coefficient of my base is this negative sign. This negative sign tells me that it's a reflection across the x-axis. Your H value is a number that's up here in the exponent with x. I don't have a number that's up there with the x. I do have a k value. We said earlier that our k value is -3. So if k is -3, that means that my graph has been translated down 3 units from my original parent function. So this graph has 2 transformations. Your domain are your x values from left to right. My graph is going to the left forever, so that's going to -infinity because my x values are going to get more and more negative. My graph is going to the right forever, so my x values are going to get more and more positive. So that's going to positive infinity. So my domain is from negative infinity to positive infinity, which is the same thing as saying all real numbers. Remember, we said before that this will always be your domain every time you graph an exponential function of this form. Your range is your y values from the bottom of your graph to the top of your graph. My graph is going down forever, so that's going to negative infinity. The top of my graph is my asymptote, so that's going from negative infinity to 3. I could also write this as an inequality. See here how my curve is below my asymptote? So everything is less than my asymptote. So I'm going to have y is less than negative 3. Your x-intercepts are where your graph crosses your x-axis. Remember this right here, this line right here, this is my x-axis. Well, this curve does not cross this x-axis, and it will never get a chance to because of the barrier of my asymptote. So I'm never going to cross my x-intercept, so I don't have any x-intercepts. To figure out if it's increasing or decreasing, you trace your graph from left to right. From left to right, it's going down, so it's decreasing. Your y-intercept is where your graph crosses your y-axis. Well, that's crossing right here at the point 0, negative 4. For our end behavior, as x approaches negative infinity, this is telling you to look at the left side of your graph. On the left side, that's over here, my graph is getting closer and closer and closer to your asymptote. My asymptote is at negative 3. As x approaches positive infinity, this is telling you to look at the right side of your graph. Well, the right side of my graph is going down. That's going to negative infinity. When you're doing this side will always be negative infinity, this side will always be positive infinity. One side for the left, one side for the right. This part you're saying what y is doing. Your only options are up, down, or asymptote. If it's going up, it goes to positive infinity. If it's going down, it goes to negative infinity. If it's leveling out, then that's going towards your asymptote. In this problem, my asymptote is at negative 3.